Okay, students, this is the video for reviewing for Chapter 5 for your test on Friday. So make sure you have the correct video. And let's start off with number 6. Give me just a second here to get my pen. And here we go. Number 6. The directions to state whether angles L and R are corresponding angles or not. And so look at your triangles here. Angle L has 2 marks. Angle R has 2 marks. And actually I copied that wrong, so give me just 1 second. I apologize. Problem number 6, those are the wrong angles. Okay, let's try this again. Angle J and angle R. Alright, so angle J has 3 marks, angle R has 2 marks, so no, these two angles are not corresponding angles. Let's take a look at number 7. Number 7 wants us to compare segment or side KL and QR. So look at the given diagram. KL has 1 mark, QR has 1 mark, so we say yes, these two sides are corresponding parts. Alright, let's take a look at number 8. And again, I'm going to go fast. You can pause if you need to. Number 8, we're comparing angles K and Q. So let's take a look at those. Angle K has 1 mark, angle Q has 1 mark, so yes, they are corresponding angles. Okay, let's take a look at number 9. Number 9, we're comparing PQ and LJ. So PQ is this side right here. It has 2 marks. LJ is this side. It has 3 marks. So no, these two sides are not corresponding parts. All right, let's take a look at number 10. Number 10, we are comparing JK and PR, those two sides. Well, let's see. JK is right here. It has 2 marks. PR is right here. It has 3 marks. So the answer is no. These are not corresponding parts. Let's take a look at number 11. Number 11, we're comparing angles R and L. Alright, angle R is right here. It has 2 tick marks or 2 marks. Angle L is here. It has 2 marks. So we say yes, these are corresponding angles. Corresponding angles. Okay, moving on. Next, your review sheet says to do 12, 13, and 14. And let me quickly look at the directions here. It says to decide whether enough information is given to show that the triangles are congruent. If you feel like there is enough information, then tell which postulate you would use. So, we have what? Side, 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 angle, angle, and angle, angle, side. Of course, we have hypotenuse, leg too, but I don't think any of the triangles are right triangles. And don't forget that hypotenuse, leg is only a theorem that works when dealing with right triangles. So we're going to cross that off. Okay, let's take a look at number 12. It looks like to me that we have a side here congruent to a side over here. And we have a side here congruent to a side here, and notice they both have an included angle. That means this angle is right in between the two sides. So yes, you can state that these two triangles are congruent, and the reason would be side, angle, side. Okay, let's go on to number 13. Number 13. Well, looks like we have a side right here congruent to this side, and we have a side here congruent to this side. And it looks like that's all we have, but hold it, please don't forget that when two lines intersect, their vertical angles are congruent. So this angle right here is congruent to this angle here. So we have side, angle, side, congruent to side, angle, side. So yes, you can definitely state that these two triangles are congruent by side, angle, side. You know what we need to start practicing? Let's go back to number 12, because on your test, I'm going to want you to write the correct congruent statement. So here we would say yes, and then you would say triangle DEF. Now make sure you get it right. Is congruent to triangle. Now be careful. D is on the side with one mark right here. So come over here, and here's A. It's on the side with one mark, so A comes first. Next is angle E. Notice how angle E has one mark, and so does C over here, so C comes next, and then B. Okay, now let's go back to 13. You would say triangle PTQ is congruent to triangle. Okay, now P right here, this angle right here, is at the end of the side with two marks, so that would be R would come next. Your second letter is T, that's right in the middle right here, so T would come next. And the only thing left then would be S. So let's practice that from now on. Okay, it's kind of funny. Number 14, do you notice this black line I've drawn right here? Now I'm making it red. They forgot to put that in the book. I am sure of that. They meant to put a line right down the middle so that you had two triangles. So that's kind of funny that they forgot to do that. So go ahead and fix that. And I think it would help us if we maybe took this. Well, you know what? That line's not going to move with me, but I think it would be helpful if we took this picture and turned it maybe like this. And give me just a second to do that. And then, of course, let's get rid of this. And the triangle is bent a little bit because the book, when I scanned it into the computer, it's going to be a little distorted. But they really wanted to have this line right here drawn, I'm sure of that, and they didn't. So there. So basically what we have are two triangles. You have a triangle like this if you want to split it, and a triangle like this, if that helps a little bit. And we have two marks here, so we have two marks here. We have one mark here and one mark here. Alright? Okay, let's see what we have here. If you'll notice, these two triangles share this side right here, so I can definitely state that this side here is congruent to this side here. And I'm going to go ahead and put a Q here, an R here, and a P up here, and an R here, and an S here, and a P here. So yes, students, we can definitely state these triangles are congruent by what postulate? Side, side, side. And write your congruence statement correctly. Triangle QPR is congruent to triangle. Now here's Q. Q's on the side right here. See this angle? It's the angle that has the 2 mark and the 1 mark. So here's the 2 mark side hitting here. Here's the 1 mark side. So over here, here's the 2 mark side and the 1 mark side hitting at S. So S would come first. Or yeah, it would come first. P is here, and P's up top. That would go along with P over here. And of course, the only other angle left is R. So there we go. Okay, that's numbers 12, 13, and 14. Let's continue on to number 15. Number 15. The direction state. Let me go ahead and write that right here so we know where we're at. And I need to label this one also so students can see that. Alright, number 15. Determine what information is needed to use the indicated postulate or theorem. So, in number 15, I accidentally cut this out of the book, but what it says for number 15 is they want you to use the angle, side theorem. So angle, side. Now look, students, here's your side right here. Do you see that? And here's your angle, okay? You want another angle. Now you don't want this angle because that wouldn't be angle, side. That would be angle, side, angle. And that's not what you want. But if you had this angle here, that would be angle, side. So I want this angle. Let's come over here. I don't want this angle here because that would be angle, side, angle. I don't want that. So the angle I want is going to be this angle up here, and look what I have. Angle, side. So what am I missing so that I can use angle, side? I'm missing angle S being congruent to angle X. That's what I'm missing, okay, in order to use this right here. Alright, let's go on to number 16. Now I accidentally cut this out of the book, but number 16 says they want you to use the angle, side, angle postulate. So let's see what we're missing here on our congruency marks to make this possible. angle, side, angle. Well, it's got to be this side right here, does it not? Look, here's your angle, and then you want a side, and then an angle. So I know for sure I want this side here, GF. Now let's come over here. Well, students, it's got to be this side here because I've got an angle, and then a side, and then an angle. So what I'm missing to be able to use angle, side, angle is GF congruent to AB. You got to have that, okay? If you want to use angle, side, angle. Okay, moving on to number 17. Number 17. Now here, they want us to use angle, side, angle. I think it'd be pretty wise to split these two triangles up. I think that'd be very helpful. So here's K, J, M. And the other triangle looks like this, and it's going to be K, M, L. Now notice we have an angle here marked with an angle here, okay? Angle here, angle here. And obviously, I mean, they don't give you this. We can obviously see this side here is congruent to this side here. They share that side, and you want angle, side, angle. So look, here's your angle and here's your side. We must want this angle here. And then look at this. Here's your angle, here's your side, so we must want this angle here. So what we are missing to use angle, side, angle is angle K is congruent to angle M. That's what you're missing in order to use angle, side, angle. Okay, let's continue on to numbers 22, 23, and 24. These will not be fun. These are two-column proofs, so please be ready to accept the challenge on that. Okay, so here's number 22. Notice they've already given you the diagram over here, so we're good. If you'll read 22 carefully, it says use the diagram and the information given in number 19. So if you'll look up at number 19, please look up at number 19. They give you AC is congruent to BD. Do you see that okay? If you look at number 19, they give that to you. They also have these right angles marked, okay? That's also given to you. So I'm going to go ahead and write that too in my given. Angles C and D are right angles. All right. Now, what are we proving? Well, look at number 22. Number 22 says they want us to prove that angle CBA is congruent to angle DAB. Now, students, let's take our time on this. The first thing you want to do, I'm going to write it real small, but you want to split your two triangles up. You definitely want to do that, okay? So, very quickly, split your triangles up. This is triangle CAB, and this is triangle DAB. Let's go ahead and put our right angle symbol here and our right angle symbol here. Now, do you see what we're trying to prove, students? We're trying to prove that angle CBA, this angle right here, is congruent to DAB, this angle right here. Now, the only way to do that is to first of all state that we'll call this triangle 1 is congruent to triangle 2. So we're going to have to prove that these two triangles are congruent, and then after we state that, we can then state that these angles are congruent. Now, how are we going to state that these two triangles are congruent? Let's lay out a plan of attack, okay? Let's first of all get everything marked over here. Look at our given. AC is congruent to BD. So let's put a mark right here, AC and BD there. Well, it looks like to me we're trying to see, okay, we do have, remember this, we do have right triangles, okay? And whenever you have right triangles, all that you need is the hypotenuse and the leg to be congruent. All right, now do you see, right now I'm just laying out my plan of attack, okay? Do you see how they share this side right here? Do you see that? So we know that we're going to be able to state that this side here is congruent to this side here. And what is this side called? Isn't that the hypotenuse? And what is this side called? Isn't that the hypotenuse? So we have the hypotenuse congruent to the hypotenuse, and we have a leg congruent to a leg. So we can definitely state that these two triangles are congruent by using what method? HL. So that's our goal. There's our plan of attack, okay? So not really trying to be fancy. I'm just going to be real quick here. And I'll have to erase a lot of this, but our statements will go here and our reasons will go here. Now I've told you before, you're more than welcome to put the number 1 and put a line and come over here and put your given. Okay? Now look at what you're given. All that you're told is AC is congruent to BD. Do you see that? Nowhere do we state that we have right triangles. Students, you cannot use HL unless you state you have right triangles. So the first thing I'm going to state is triangles CBA and DAB, those two triangles, are what? Right triangles. Now how can I state that? Definition of right triangles. Definition of right triangles. Because look in your given, did we not already state in our given that we have right angles? Yes, we did. So as soon as we state we have right angles, we can definitely state that we have right triangles. So far so good. Look up here in your given, we have stated AC is congruent to DB. That's the legs. So we've stated the legs so far. Now we got to state the hypotenuse, or the hypotenuses. Okay, so we're now going to state that AB is congruent to AB, and of course the reason for that is reflexive. So look what you've stated now in your proof so far. In your given right here, you already have written, when you wrote this slash right here, you were really copying all of this down here. So really what you had stated is AC is congruent to BD. So let me switch colors here. So you've stated your legs, you've stated you have right triangles, you've stated your hypotenuses are equal or congruent. So now you can state that your triangles are congruent. Triangle ACB is congruent to triangle, and that's wrong, triangle BDA. Okay, and the reason for that, remember, HL, hypotenuse leg. Now once you state that the triangles are congruent, you can definitely state that angle CBA is congruent to triangle D, or to angle DAB. And of course the reason is CPCTC, or you can just simply say corresponding parts are congruent. Okay, I know these are not fun, I know they're decently difficult, but geometry is all about two-column proofs. We have 2 more to go, and then we'll just have some easier problems after that, and we'll be done with the review sheet. Okay, students, let's move on to number 23. 2 more two-column proofs. Number 23. Okay, first of all, it says use the diagram for exercise 20. So here's exercise 20, and if you'll look at 20, they give us this. So here's your given. In exercise number 20, they say MN is congruent to KL. All right, so there's our given. And it looks like also we have, I'm going to go ahead and say some right triangles this time. We can do that. I mean, I probably should have done that in the past proof. I mean, they're giving us the diagram right here and saying use the information. So I'm gonna go ahead and say triangles JMN and triangle JKL are right triangles. We can say that. That's given to us, those marks right there. So there we go. And then what are we trying to prove? Well, we are trying, sorry about that, we are trying to prove JM is congruent to JK. Now again, for the 100th time, the only way you're going to be able to prove these two sides are congruent is to first prove that the two triangles are congruent, and then you can state their corresponding parts are congruent. And you can see right away, I think, students, that we're going to need to draw two different, we need to split these triangles up. So here's one triangle coming down like this. We're going to call that J, L, K. And then the other triangle, come up like this, and then down, and then over, and we're going to call this J, M, N. Okay? And it looks like we have a right angle here. That's from right here. It looks like we have a right angle right here. That's from right there. And let's pick up our given and mark it in the triangles. Notice they give us this right here, MN congruent to KL. So MN is congruent to KL. Now what I'm looking for, students, is do these two triangles share anything? And I'm going to highlight one triangle in red for you up here. Okay. Now I'm going to highlight the other triangle in green. And you're going to see they share an angle to the left over here. So there's the green one. Do you see how they both share that angle right there? They both have that common angle. So because of that, what I can do, and again, I'm trying to think how I can prove these two triangles are congruent. Well, look, if I can state that J is congruent to J, would you please look at what I have? I have angle, angle, side congruent to angle, angle, side. So I can definitely state that these two triangles are congruent, and my plan of attack is going to be this, angle, angle, side. Okay, so here we go. I'm going to go ahead and draw a crossbar here and this coming down, and I'm going to go ahead and put my given, I guess this time. I'm going to go ahead and put it so we can see it. You don't have to if you don't want to. MN is congruent to KL. All right. And then your triangles, I'm just going to put the triangles are right triangles. Okay, and that's our given. So there we go. Now, by the way, we have right triangles. We're not going to be able to use HL, so we're going to have to use angle, angle, side. But look what we already have stated right here in our given. There's our side. We've already stated our side. So all that we have to do now is state that angle K and M are congruent. We can state that, can't we? We can say angle K is congruent to angle M. And how can I state that? All right angles are congruent. There we go, just like that. All right. Now, I've stated this, KL and MN, that's right here. And now I've stated this angle and this angle, that's stated right here. And now lastly, remember we got to state they share the angle J, so angle J is congruent to angle J, reflexive property. There we go. And now you've stated this, you've stated everything, you've stated your angle, angle, side. So now you're ready to state that triangle JLK is congruent to triangle, let's see what we have here, JNM. And what would the reason be? Angle, angle, side, right up here. Angle, angle, side. And I'm going to squeeze it in real small. Once you state that these two triangles are congruent, look at your proof part. You can now prove that. You can say, well, because these two triangles are congruent, I can now state that JM is congruent to JK. And my reason would be, whatever you choose, CP, CTC. I love using that. I think it's the fastest way to do it. But if you don't like that, you can just simply write it out. Corresponding parts are congruent. Okay, one more of these torturous things and we'll move on to some easier math. All right, number 23. Now, number 23 says use, or did we just do 23? Let's take a look here. Yeah, we just did 23. So, on to number 24. All right, 24 states use the diagram and the information in exercise 21. So here's the picture for 21. And they do give us, if you'll look in your books at number 21, they give you this right here. PR is congruent to TR. They give that to you. And looking at the picture, we can definitely state that our triangles are right triangles. All right. Now we're going to prove QR is congruent to SR. Now it sounds like a broken record, but again, I cannot prove that unless I first prove that these two triangles, 1 and 2, are congruent to each other. And once I state or prove that those two triangles are congruent, then I can state that these sides are also congruent. Let's go ahead and lay out our plan of attack here. I don't think I need to split these triangles up. First of all, let's pick up our given and put it on the picture. So PR congruent to TR. Well, here's PR right here, PR, and here's TR, so we know they're congruent. Well, students, this is really simple. I mean, look, we know that vertical angles are congruent, right? So we can definitely state that that angle there is congruent to that angle there. Look what you have. And we know that right angles are congruent, so we have angle, angle, side, congruent to angle, angle, side. So that's going to be our plan of attack. We're going to have to use angle, angle, side. Okay? And that's pretty simple. I think you guys really should be getting this by now. You do not have to write out your given if you don't want to. I'm going to go ahead and do that just very quickly. I'm going to write, and I'm being pretty sloppy here, but I'm trying to save time. PR is congruent to TR. And I'm going to put a slash, and your triangles are right triangles. I don't mind using abbreviations like this as long as I can read them on your test or quizzes or homework. Okay, now would you please look at what we've already stated? We already stated PR is congruent to TR. That was given. So we've got to do angle, angle, side. So there's our sides. Now we just got to list that our angles are congruent. Well, guys, I can definitely state that angle Q is congruent to angle what? S. And what's the reason for that? All right angles are congruent. So there we go. We just stated another part. Now we just need one more angle. Well, I can state that angle PRQ, you see it? PRQ, this angle right here, right there, is congruent to angle TRS. That would be this angle right there. Angle TRS. And how can I state that? Well, we have a theorem. Hopefully you learned it last semester. It simply stated that vertical angles are congruent. There we go. So look what you've stated. You've stated your angle, and your side. So now you're simply ready to say triangle PQR is congruent to triangle TSR. And the reason, of course, is angle, angle, side. And then once you state the triangles are congruent, you can now state that QR is congruent to SR. And I really like CP/CTC, but if you don't, that's fine. You can just simply write out corresponding parts are congruent. Okay? I am going to give you one of these, one proof. Now, you know already you're proving that one theorem proof that I've told you you're going to do. Then I will also give you another 2-column proof on the test. So one you can have memorized. If you'll really work hard, you can do that. And the other one you'll have to solve on your own. Okay, students, we have only 3 problems left, so hang in there. Just about done. This is number 25. Number 25. It's a little blurry, but you can see this in your book, of course. All right, number 25, look what we have. I'm going to highlight it for you in red. We've got a big old angle right here. See that? And see, that's a big angle. And then notice how this little angle here is congruent to this angle here. That tells me I've got an angle bisector. That means this line right here that I'm going to highlight in blue, that's an angle bisector. Now remember the theorem we learned the other day? We learned that if an angle is bisected and there's a point on that bisector, that point is equidistant from the angle. Okay, so if this is 3, which it is, then how big or how long does JM have to be? Well, that's pretty easy. 3. Side JM has to equal 3. All right, let's take a look at number 26. All right, number 26. Now, this is the other theorem called the segment perpendicular bisector. All right. Now, here's your segment right here. There's your segment. And this is your perpendicular bisector. How do you know that, Mr. Earhart? Well, first of all, I know it's perpendicular because of the right angle symbol. And I know it's a bisector because, look, they're telling you PS is congruent to RS. And so that means this line is cutting the segment in half. Now, what you learned was this. In the perpendicular segment bisector theorem, you learn that whenever a segment is bisected by a perpendicular line, this point right here on the perpendicular bisector is equidistant to the endpoints. So that means this line right here has to be the same as this. So that means I can definitely take x plus 4 and set it equal to 2x minus 1. Now, if you subtract 2x from both sides, you're left with negative x. And if you subtract 4 from both sides, you're left with negative 5. So if negative x equals negative 5, there's basically a negative 1 there. So we just divide both sides by a negative 1. X equals 5. They did not ask me to solve for x. They asked me to find the length of QR. And the length of QR equals 2x minus 1. So where the 5 is, or where the x is, we're going to substitute a 5, and the answer is 9. The answer is 9. Okay, moving on to number 27. And again, I know I go faster than usual. If I was in class, I'd go a little slower, but you can back this up and listen to it. So, all right, and I just put number 29, and that should be number 27. So last one, and we're finished. So congratulations for hanging in there. All right, let's see what we have here. Okay. We have an angle. I'm going to highlight it for you. We have a big angle there and there. There's the angle. And that angle is being bisected, cut in half by this line right here. How do I know that? Because look, there's a little congruent sign there and there. So if this angle with a dot and this angle with a dot, if those two angles are congruent, then we know that this is a bisector. It cut the angle in half. So here's the theorem that you learned called the angle bisector theorem. If an angle is bisected like this, then the point that lies on the bisector, point Y, is equidistant to the angle. So this line right here is the same as this one here. So I can definitely say 3x plus 4 equals 6x plus 1. Well, let's subtract 6x from both sides. That leaves me with a negative 3x. Let's subtract 4 from both sides. That'd be a negative 3. Divide by a negative 3, and x equals 1. They did not ask us, though, what x equals. They asked us to find the length of xy. The length of xy. And xy is 3x plus 4. So where the x is, I'm going to substitute a 1. And we can see the length of xy equals 7. It equals 7. Okay, hope you've studied hard for this test. Please do study. If you finish the entire review sheet, it is 5 bonus points. Mr. Harmon was supposed to tell you that in class, so I hope that he remembered to do that. Your test is Friday. I hope that you'll do well and work hard and study hard.